Okay. Everything is set up. I hope the audio setup works fine. I really do. Okay. Probably the volume is a little low. Sure. Yeah. Sounds a little low. Hello, 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 hello. Much better now. I'm almost done with these exercises. I'm at chapter 8. I think we have 10 chapters so far. Yeah. Just 3 chapters left. I'm kind of struggling with these last 1 chapters, so I hope this won't go too bad. Anyways, after a brief hiatus, yeah, I stopped to. Did I do some of this already? I don't even remember anymore. Yeah, I already started this. I guess reading the chapter again won't do any harm because I don't remember anything about it. Okay, so Haskell in general loves the notion of type polymorphism. Let's take a nice familiar function. So we have an ID, goes from A to A. This function is totally polymorphic in its A variable. You can give it any type of value and you'll get a value of the same type back. Now let's write a type family to do the same. So we have a type family ID, which takes an X of kind A, returns a kind A. And we need the PolyKind extension enabled to write this kind of code. Let's look at another example, or humble proxy type. So if you type this into GHCI and then ask for the kind, you'll get nothing too surprising. So it takes a type and returns a type. Of course. But if we enable the PolyKinds extension, the kind changes. So it takes any kind and returns a type. Okay. The only thing worth mentioning, which won't bother us too much in these exercises, is that kind polymorphism has a trick that type polymorphism doesn't have. You can pattern match the types within kinds in a kind polymorphic type family. You can pattern match on types within kinds in a kind polymorphic type family. Okay. So we have this type family smuggler, which takes X of kind K and returns a kind K. Okay, so we can, pattern match and return the same kind. So if we have an IO, we return an IO. If we have an int, we return an int. It's actually complaining. Oh, IO is not in scope. It seems that while we say that this function works for any kind, we actually can inspect the kind in our rules. As a result, type families are necessarily parametric. Okay, so let's go back to the exercises. PolyKinds exercises. One, let's look at the following type family to build a constraint. So we have a type family all, which takes a constraint constructor C, takes a list of types, and returns a constraint. So if we have an empty list, we return an empty constraint. Otherwise, we apply the constraint constructor to the first element of the list. And then there's a nice thing about constraints that if we have nested tuples, they get flattened. So this is basically like concatenating all these constraints together. Why does it have to be restricted to type? Can you make this more general? So did I try doing this? I guess so. And it looks like it works. And I guess we needed the PolyKinds extension to do this. Why does it have to be restricted to constraint? Can you make it this more general? Why is it harder? So I wrote something here. So we have this type family which takes C. It looks reasonably fine, and I don't get any compiler error here. I wonder. If this is actually correct. So create this hlist data type here, and then I try doing this. I'm confused because I get no error. It's probably because there's something wrong with my setup. So let's try Cabal REPL. I got in the wrong chapter. Erase. I'm getting an error. It's complaining about p.show line 48. Can we? Why did I do this? And why do I have two versions of this? Let's try commenting this for now. So my first question is why I'm not getting any error here inside of Emacs. LSP restart workspace. It's kind of annoying. So I'm getting an error. Could not deduce all. Oh, because I'm using the first old here. Okay. That's why I have two versions, of course. Could not deduce all. Tick show access 1. Arising from the user show tick. Yeah. Why is it not enough for me to have this here? Doesn't trust us. Let's see if I did something similar in the previous chapters. So let's 07 exercises. Oops. 07 exercises. We have an H list. I'm assuming that if I use all, it should work, right? Yeah. So the implementation is correct. The problem is when instead of returning a type, I'm returning type of any kind. I don't know why it's not possible. 2. I don't want to spend the whole evening working on this stuff that we already worked last time, so I probably don't know the solution, the answer to this. Sometimes we're working with a lot of values, and we like some way of identifying them for the compiler. We could make new types, sure, but maybe there are loads, and we just don't want the boilerplate. Luckily for us, we can introduce this new type. So we have a tagged data type, which takes a name, which is a symbol, takes a type A, and it just wraps the type. So tag is just like identity, except there's a type level string attached to it. This means you can write things like this: tagged important int, tagged not so important int. What's more, we can use that tag in function signatures to restruct the input. So it takes a tagged important int. Okay. Symbols are all well and good, but would it be nicer if we could generalize this? I guess so. Can we generalize type? If so, how? If not, why not? I think we can't because the runtime values all must have can type. So if we generalize this one, then at runtime we have something that's not a type. Maybe it's why this wasn't working here too? Nah, probably not. Right, this one. So we have this data A. Yeah, it was the sad smiley. A said smiley, B crying smiley. What's the kind? Takes a kind, another kind, returns a type. I guess we can ask GHCI. Why is it not scope? Slices. Kind. Crying smiley. Yeah. Does PolyKinds make a difference, this kind? Yeah. I think without PolyKinds would be fixed to types, or would probably be an error if I try to use it. Regardless of your answer to part B, is this the most general kind we could possibly give this constructor? If not, hint, it's not. What more general kind could we give it, and how would we tell this to GHC? And I answered, I have no idea last time, which is very encouraging. Well, I'll trust my past self and I'll stick with the I have no idea. Maybe these two kinds don't have to be the same. Could it be something like this? Oh, come on. Where's the... kind 1, kind 2, star. But then I don't know if the compiler will complain because, yeah. I don't know. It doesn't do anything with this B, right? Oh, who knows. Okay, 4. Did I do this? I don't think so. We talked about singleton types previously, and now they allow us to share a value between the value and type levels. Libraries such as singletons provide many utilities for working with these types, many of which rely on a type level function to get from a kind to its singleton. In our toy version of the library, that type family will look like this. Okay, so we have a type family sing, which takes an X of kind K and returns a type. Notice that it's an open type family. Thus, we define instances for it using the type instance sing X. Oh, okay. Completely forgot about the syntax here. Okay, here's the singleton for the bool kind. Remembering that the singleton for some x of kind bool is s bool x. Write sing instance for the bool kind. Remember that we can pattern match on kinds in type families. If you're on the right lines, this is a one-liner. Okay. So we have a type instance sing okay. I guess this is the easy part. I should put some compression on my voice, I think. This probably would be much better. Okay, type family sing. Where is it? Sorry, type instance sing. Kind of randomly guessing for now. And also, yeah, I'll have to reload here. Expected a type. Alright. We're working the type level, not at the value level. Right. Well, this doesn't make much sense. Yeah, loads, but this feels very wrong. Well, S bool wraps the bool type, right? Is it this? Expected a type, but B as kind bool. Oh yeah, this is the kind. not a type. I feel like I forgot everything. Okay, wait a second, because so this thing takes a kind. Type of kind K, which is this kind here. So I don't have to wrap it in sbool. This is the thing of B. Is sbool B. Is this correct? I think so. Because this now is a type which I can construct passing the kind B, which is the argument to thing. I'm assuming this is correct. Repeat the process for the not kind. Again, if you're on the right lines, this is very nearly copy-paste job. So we have a type instance thing, which takes n. Is this the solution? Yeah. Five. Independently typed programming. We talk about the notion of a sigma type or a dependent pair. Interesting. This is a single constructor JDT that takes two arguments, a singleton for some kind and some index by the type represented by the singleton. Don't panic. Okay, thank you. Let's do an example. Consider the following JDT to describe a fixed length list of strings. Wait a second, I'm gonna try putting a compressor on my voice. Is it filters? Let's add a compressor. Is it already working? I have no idea. Hello, hello? It's probably working, yeah. Let's see if this is better. Sadly, there is no one in chat who can give me pointers. Okay, yeah, it looks much better from the bars down here. Consider the following GADT to describe a fixed length list of strings. So we have a data string which takes a nut, and we have two constructors. Okay, yeah, we have the usual nil constructor and our const constructor. If we have a working sigma type, we should be able to package. Yeah, it's too strong. To package a strings n and s not n into sigma strings, existentializing the actual length. Okay. We have an example which is sigma strings. It's sigma as z as nil, sigma as, okay, interesting. So now we have a list of length encoded lists, or they have all different lengths, and this compiles. Okay, because obviously if we try to do something like without this sigma stuff, we can do that, because we have to have like all strings of length that's 0, for example. We can mix different lengths, but we can with this sigma stuff, which is pretty cool. And the problem is that now we have to write this types definition. So we have a data sigma which takes an f, which is a function goes from natural to a type. The compiler should do a lot of work for you. I guess so, but the problem is that it's not working for me now for some reason. Well, let's try. So we have let's try doing this. Oh yeah, wildcards are not allowed here. Very helpful. So this is a single constructor GDT that takes 2 arguments, a singleton for some kind. So let's say it's short. A singleton for some kind. Some type indexed by the type represented by the singleton, which is our strings in this case, which is a constructor that takes nat and returns a type. Strings k. This doesn't feel very right to me. I'm not doing anything with this f. Well, let's see if I can just uncomment this. Let's see if this works. Yeah. What if I use the f here? Still works. And looks like a much more correct solution. I'm gonna keep this one. Surely by now you guessed this question. Why are we restricting ourselves to nat? Then we have some more general way to talk about singletons. The family of singletons. Yes. Anytime within the family of singletons, sing it with me, generalize that type. Oh god. Gonna comment this one. So we can generalize this. So we still have an f, assuming, which is not gonna take an at anymore, but it's still gonna return a type because we have to have return types at runtime. He's gonna take something else, and he's gonna return a sigma of f. Why are we restricting ourselves to NAT? Now we have some more general way to talk about singletons. The family of singletons. Actually, I'm confused because it's this one, it's the same I used here. I mean, this is probably not going to work, but I'm just gonna try anyways. It actually works. It looks too simple to be the correct solution. I don't know. But it works. I don't know. Can you do like a kind example? Kind example. Kind example. Wait. Okay, because it's not a type variable, it's a value. Yeah, we can show this. I assume it's correct. Looks too simple. It compiles. In exercise 5, we wrote a filter function for a vector. Could we rewrite this with a sigma type, perhaps? Let's go back to the exercises here. And here's our filter function. I'm just gonna copy it here. This is the chapter 5 implementation. So we took a vector, an a function, goes from a to bool. Yeah, it's about rank-n types. So and then we take a function that does something with the resulting vector, and then we return a result. And now we want to do this with our sigma. Okay. So I guess let's start writing it. Oh, hi. Hello. This is my first raid. It's very exciting. How's it going? I'm struggling a lot here. This PolyKind stuff is very confusing. And now I'm trying... Oh, that's cool. Yeah, I can. There's a big... Probably this team is not the best. I'm stuck here. Well, I'm not stuck. I just started, but I'll probably be stuck. I need to write this filter function for vectors by using this sigma stuff, which was introduced in this exercise, which is a dependent pair. Yeah, it's a way to have polymorphic kinds. It gets very confusing because it's something that, at least talking for me, I'm not used at all working with, and it's very mind-bending and very tiring. So the point is that last time, a few chapters ago, we had to write this filter function for vectors, which uses rankine types. And now and now he wants us to write it again by using this sigma thing. And I guess this is not correct. This is gonna take a vector and a. It's gonna take a function to filter this vector, and then we're gonna return something here, which I'm gonna assume is gonna be a sigma. It's gonna be a sigma of a vector of a. Okay, I have to comment this one. And it's already not working because he was expecting a type, but A as kind nat here. A is a natural. So this function is not correct. But it worked here. Why did it work here, not here? Let's try putting just unit here for now. Oh, my bad. I I switch these around. This should work. Yes. Okay, good. Good. Now let's see if this works. Which I don't need this parentheses here. I think it's the ambient track list on Pretzel Rock. I installed this the other day because I was using Spotify, but even with all those like copyright-free playlists, I was getting complaints from YouTube and Spotify and Twitch, and looks like my videos were banned in Belgium for some reason, so I stopped. Yeah, it's chilled. I don't like chill. I tried it, and it's not really chill. If it makes sense. Anyways, I got the type signature, which is probably reasonably correct. And now the problem is writing the body. So let's start with the empty vector. So if we have an empty vector, we don't care about the function. We filter in function, and we return a sigma vinyl. Which doesn't work. Nice. Couldn't match expected type sigma of vector A. The actual type goes from f0k1 to sigma f0. Oh, because sigma takes two things. My bad. So this is gonna be a sigma sz. So it has the length of 0 encoded as a phantom type. Is it a phantom type or a phantom kind? I don't know. I don't know what I'm talking about, but anyways, I'm gonna assume that this works because it's pretty similar to the strings implementation and makes sense to me, and the compiler is happy. And now we need to write this filter function for the non-empty vector. So we're gonna have a vconst AAS. I'm gonna have a function f, and we have to return something. We have to return something. So we have two cases. So we have a case where this predicate fails. So in that case, we just discard this first element. So we can say that if px do something, otherwise we just return filter v of as f, which this one should still type check. It doesn't. It's not a predicate. F a. Okay. Cool. Okay, I guess in their case we need to do some kind of recursion. Let's see what the compiler tells us. So there's an hole, which is a sigma vector of A, which, yeah, it's not very useful. So we can create a recursive function. We're gonna do something with our first value, and then we need to do something else with the tail. Probably pass again filter v. I'm not sure. So let's see where this takes us. So we are a go function which takes an a, takes something else, returns a sigma vector of a. This looks very hard. if anyone in chat, oh bye. If anyone in chat knows how to help me, some hints or some ideas, please feel free to write something, because I'm a little confused. Probably have too many olds, that's why it's complaining. And it's not being very helpful. Yeah, still too many type holds. I'm gonna assume that you're calling this one recursively here. And so this one is gonna be sigma vector of a. The compiler is happy so far. So this is a sigma vector of a. How are we gonna work with this type here? So sigma of a vector of a takes the singleton, so we have a sigma help. Let's try keeping it simple. I don't know if I can destructure this. Let's do this. So we have a sigma which calls the singleton, which encodes the length of the vector. And then we have the vector constructor. And we're returning a sigma. Found all, which is a vector a1 k0, where k0 is an ambiguous type variable. a1 is a rigid type variable, bounded type signature for Go. So this one has to be a vector. Okay, so now we got to the other hole, which is still a vector, of course. So it's a vector a1 and 0. The relevant binding is closed. We have VA, which is a vector. Vector a1 k. Which k is not the same, but I'm gonna try sticking in there for now. The compiler looks reasonably happy for now. And now we get to the other type hole. So we have a hole which is of type A1. And if we look at the relevant bindings, we have X, which is an A1. So I'm gonna stick it there. Is it n+1 XVA for the olds? Yeah, I think XVA are probably correct. I don't think I can do n+1 because this one is not an int. This one is a singleton. So it's not actually. I mean, at the value level, it's completely useless, more or less. Or maybe yeah, we can. Oh wait, maybe you're right. But we can write like this successor then. This actually compiles. Yeah, this compiles and also makes sense. So we have the base case where we match the empty vector and we return our sigma of zero length. Yeah, I don't know. This stuff is so hard. I mean, sometimes I can get to the solution by using the compiler, but I would never write something like this on my own. I'm glad you're understanding because I'm not. I feel like I'm stumbling in the dark, and sometimes I get hold of a handle or of a small light, but I'm going completely aimlessly. But yeah, this kind of works. So yeah, we're building a sigma. Yeah, GHCID is cool. I think it doesn't work here for some reason. I tried last time. Maybe it works. I don't know. Oh yeah, it works. Yeah, it's much better. I don't have to reload manually. Okay, let's go to number 6. Our sigma type is actually very useful. Let's imagine we are looking at a communication protocol over some network, and we'll label our packets as client or server. Okay, client data and server data are different, however. So client data holds a name and a favorite int, and server data has a favorite bool and a complementary unit. Yeah, it's much better. Saves keystrokes and time because I don't have to switch window. It reloads while I'm doing something else. I don't know why, but the language server protocol stopped working for this project for me, and I gave up on it. Anyways, write a GADT indexed by the label that holds either client data or server data. So we have data communication, which is indexed by the label. Okay. I'm gonna do this. Yeah, it's a bit of a weird project. So I'm gonna guess we can have a client com which returns the communication, client, and a server com which takes something and returns a communication server. Yeah, that's why I gave up. Also, this is a virtual machine I use at home. I don't want to waste time trying to chasing language server protocol or the other stuff. This works fine enough. So sadly, when we work at type level, the holes are not useful at all. So we have something here, which I'm gonna assume it's gonna be client data. And server data. Write a singleton for label. I'm cheating by copying from the other implementation I did earlier, but okay. Magically, we can now group together blocks of data with differing labels using Sigma communication, and then pattern matching on the Sigma constructor to find out which packet we have. It is a bit. If I did write it again from without looking at the old one, it would stick much more in my head. Said this way, I probably forget about it in 10 minutes. Yeah, true. So, server log, we have a Sigma communication, a list of Sigma communication, and we return a list of server data. Oh, so basically we're filtering our list. So if we have an empty list, I'm gonna return an empty list. Yes, this was easy. And then we're gonna have a Sigma. Just gonna check step by step, doing very little steps if things compile before moving on. So this one looks fine. So we can pattern match, right? So I feel like we can do something like this. Oops. So Sigma takes a constructor, goes from a kind to a type. which is our S label. So let's try this. Let's label S labeled server, return D, and we append it to server log access. Otherwise, or just return server log access. And it doesn't work. It doesn't work. Can I use just a server? I think I have to use a server here. No. Couldn't match expected type sing k. Oh, I have to use sing. Yeah, of course. It's so hard to keep track in your mind what's at the type level and what's at the value level. So this is wrong. Okay, let's just ask the compiler. Could not match type communication K with server data. Sigma of communication. So communication is our F. So let's try writing things down. So communication is our F. Label is our K. Okay. So what if I do this? Okay, so this D, I can't use this D here because this D is a communication K, of course. Of course, I'm doing this wrong. Okay, I think. Yeah, okay, the compiler doesn't give me any error, but I'm sure this one is not correct. Or at least it's not complete. So let's try again. I need this back here. I don't know, it looks still correct. really trust this stuff here. I'm gonna test it. Yeah, it is a filter, because if you want to actually use the stuff inside of this sigma or pass it in a list, then we have to turn it into an actual concrete type we can use. Because I guess this is like a mixed bag, opaque bag, which we can't really use. Let's try writing some network data, which is a list of sigma communication. It's gonna be a sigma as client, client data C1. It's expecting communication of client com. I was expecting as label client. Why is it not working? Client. No. Sing client. How do I create a sing client? Can I just use the sing constructor? I'm confused. Sing takes K, which is client label. Of course, sing is not in scope. Where is it? Where are you, sing? So I need to pass value of type sing client. Do I have to write type instance sing L I'm not entirely sure about the syntax here. Can I do this? I don't think so. S label L? You mean down here? Oh no, up here, okay. Yeah, probably. And then how did I use this other one here? I didn't actually use it. Let's try. You're right. So why can I do this? Yeah, I guess so. It's very confusing. So are these like, is this like saying almost like a type class, but for, I don't know. Oh, hello, I let this spam. No, I don't want to get famous. Well, what I can kind of understand is that this telling the compiler, okay, yeah, this S label is actually a singleton. So trust me. Yeah, probably. Okay, let's try server com true. Was it complaining? Oh, server data. Okay, and then we can try doing let's do server log network data has to be equal to server data true. Okay, works. It's magic. Arguably in this case the sigma type is overkill. Is it? What could we have done? Perhaps using methods from previous chapters to hide the label until we pattern matched. I think we can do this with runtime types. Come on. Oh no, wait, no. No, that's not what I was thinking about. What could we have done? Perhaps using methods from previous chapters. I think he wants to use one of those like auxiliary type of family thing technique that he used in previous chapters, but I have no idea how to use them. So I'm gonna just check the solution for this one. I am Tom. Haskell exercises. These are PolyKinds answers. Oh, this looks a little different though. Let's check it. Communication label, client data. Okay, this is fine. As label is fine. Then I have this server log. Wait, what's it doing here? Wait, how does this work? I'm confused. Server. Server. Oh no, okay, it's fine. I was just confused because you put the C before the server. I was assuming it was client for some reason. Okay, well, you just use a map maybe instead of constructing the list. So, using methods from previous chapters to hide the label until we pattern matched. Just not use the type index. Sigma types become much more useful when we are dealing with extensible sets of data. Perhaps something like data communication, chicks label, packet data label, communication label. So net for data point tells you what the packet should look like. Yeah, I don't know. I'm gonna assume. I mean, trust him. So I'm not gonna do the next exercises, next chapters. Just wanna check how long they are. So this one, yeah, it's 10 exercises, pretty long. And the functional dependencies, it's pretty long too. I'm very interested in functional dependencies because they're used a lot in pure script, and sometimes I put them there hoping that they work. So that would be nice to understand a little better why they work and how they work. So I think I'm done with Haskell for today. And I'm